Okay, we are almost ready. Let's get started. Let me introduce Mr. Hakan first, our CEO and co-founder.
Hello, Tulay. Hello, everybody.
Hello. Let me introduce Mr. Dipen Shah, Premet Dubai Topcast reseller.
Hello, Mr. Hakan. Hello, Tulay, and hello, everyone. Ramadan Kareem to everyone.
Ramadan Kareem, thank you.
And let me introduce Mr. Dave Anderson from Gold Star Powders, UK.
Hello, Hakan.
Hello.
Hello, Tulay.
Hi, Dave. How are you?
Hi, Dave.
Good to see you.
You too.
Okay.
Okay. I will be following all your questions from chat panel. Now I close my cam, but I will be here with my sound to forward all your questions to our guests to answer. And we can get started now.
Okay, perfect. Thank you very much for joining us, and thank you for everybody to listen to us. Okay, it's a very hot topic, I think, casting. You know, I have been in the jewelry industry for the last couple of years, and I think that this is the most asked question topic where people have some issues about casting, and particularly when you look at what happened in the last 10 years or so, there are a lot of resin, different type of resins, and 3D printing has evolved. So today's topic is about casting, but casting specifically for resin. So we will be speaking about the general casting process, the investment powders, what is the difference between wax and resin. So I'll go through the presentation, and then, Tulay, you will collect some questions, and Deep and Dave, you can, just comment, and then at the end we will have a good chat together. We will speak about typical burnouts, what type of casting machines, and the casting issues. Just to, if you want to say a few words, I'll introduce our company first, and then you may introduce your company, Dave, and your company, Dipen. So, we are a company located in Turkey. Since 2013, we have been, manufacturing resins for 3D printers, and we also manufacture 3D printers for jewelry and dental. So most of our attendees know about our company. We have actually 4 offices around the world, and we are a team of engineers and chemists that specifically focus on jewelry. So we don't do industry, we don't do any other things. We focus only on jewelry and dental. Like, we manufacture, 3D printer. This is our latest DLP printer, which is very, very fast. And we also manufacture different sorts of castable resins that are suitable for a lot of different 3D printers. So we in the previous webinar, we spoke about the different type of resins that we have, and whether you can use them for LCD printers, for DLP printers, for SLA printers. But we have pretty much a good range of castable resin, and our specialty is really castable resin. So this is the topic. What is important about the resin is that you want to get basically the same casting like wax. You want to be able to print properly, and then in our case, we don't need any post-curing. And then you want to cast it in a simple way so that you will get the best result. So that's my introduction about our resin and the 3D printers. Please, Dipen, maybe you can have a few words about your company.
Yes, good evening. Myself, Dipen Shah from Premet company UAE. We are working with Topcast company since, I think, more than 15 years. So we are just as a caster guy, we are handling all specific focus on the casting industry, especially the jewelry. We have also office in India, recently in Mumbai. There also we are handling the casting and specialized in the casting. We are also the dealer of Gold Star powders since last 5 years. Fantastic products there. So we are a professional on castings.
Yeah. And we meet from time to time in exhibitions and in Turkey and in Dubai, actually.
Sure, everywhere.
And the same for Dave, actually. Last time we met in the exhibition, I think. But if you want to just have a few words about, your company.
Yeah, I think everybody knows Goodwin Refractory Services, more so the 3 brands, Gold Star Powders, SRS, and Widmix. We're now the largest investment powder manufacturer in the world.
Yeah.
We have a fantastic research and development team that they work every single day on different products, mainly for resin casting, as you've said. resin has evolved over the last 10, 15 years from what it was to what it is now. So the investment powder has had to evolve with it.
Yeah, definitely. So here, thank you for the introduction. And here, basically, I put some pictures of silver, gold, and gold and silver casting. This is one of our resin. It's the opaque power cast resin, PowerResins. And actually, if you follow well, let's say, if you have a good quality resin, good quality investment, and casting machines, and all the process that we will be speaking about, you can really have very, very successful casting using resin. So here we have an example of a filigree bangle. In the previous slides, as I mentioned, we have like some surface jewelry. You can also do like stone settings and cast directly with stones. We have customers doing it in India, in Turkey, and also in Dubai. So the main topic is, let's start to speak about the casting and how we work. So one thing is the chemistry of the resin, which I am an expert. Let's say I know that topic. And Dipen and Dave, you are very well on the chemistry of investment. So I'll be going through the slides, and then please comment, and we will speak together. So I just want to briefly mention that investment powder, some customers or some people think that you just mix it with water and then that's it. It's like a powder and it's like blaster and so on. But actually, there is a very, very specific chemistry going on there. Maybe Dave, you can have some words about it. But here I just put few slides showing that when you add water to this investment powder, the investment powder has a transformation happening.
For sure.
Yeah.
It's exactly what is written there, yeah.
So basically, inside the investment powder,
Excuse me.
Yes.
Excuse me. I have some comments that Dave, your volume is a bit low. Could you please, speak louder?
Okay. No worries.
Yeah. Thank you.
Yeah. So when you look to most used investment powders in the jewelry industry, it's made of silica, which has cristobalite and quartz in it, and it has also gypsum. Gypsum actually is the binder that is used to put it together. In the dental industry, they use phosphate-based investments as a binder, but in the jewelry industry, they use gypsum. And actually, I don't want to go through too much of the chemistry of the investment powder, but what happens is that when you add water in the gypsum, it changes its states from a hemihydrate state to the dehydrate state. And by doing so, it has also an expansion that is happening even you keep it, even when you mix and when you leave it, right?
Yep. So it gains its green strength before it goes into the furnace, and then its fired strength, obviously, after the furnace.
Yeah. So that's very important, because I think when you add water to the powder, what happens is that you need to think like it's a chemical process. And when you speak about chemical process, you need to consider timing. So you mix something. If you mix it too much, it may happen differently. If you mix it too little, if you put too much water, too less water. So that's very important. Here we have some instructions from one of your latest products, I think, Dave.
Yes.
Basically, from my knowledge, what I can say is it's very important to use deionized water, because some tap water has some issues, right?
Yes, obviously, deionized water, you've taken all of the ions out of the water.
Mm-hmm.
Some people think that deionized and like the water that in Turkey you have delivered, they believe that this is the same. It's not.
Mm-hmm.
The ions in the water make the powder set differently.
Yeah.
So using deionized water, you're using the same constant water every single mix.
And also it enables you to have the same result also every single time, because there are some additional things in the tap water. Let's make it simple. That basically change the chemistry of the investment.
For sure.
Yes.
Yeah.
Excuse me, I have one question from Mr. Mahan. He's asking, how about distilled water?
No, not distilled water. It's very different than deionized.
Mm-hmm.
Deionized, you're taking the ions out. Distilled, you're taking minerals out. It changes.
Okay, so we don't want any ions in the water. That's the first thing.
That's what you need to take out the ions.
Yeah. The other thing that I want to say is, when you do the mixing, let's say 4000 or 3800 or whatsoever, there is an important thing there, whether to use a scale or to look volumetrically. And from my knowledge, scale is the right thing to do, right?
Scale is always number one.
Okay.
Always.
If possible, use the digital scale. It's more precise.
Yes.
You say in one of the factory I went maybe 2 years ago or so. I think what happened is that they were using the scale, but the scale was not scaled. In other words, there was if you put 1 kilogram, it didn't weight 1 kilogram. So because what happens in large factories when you use nonstop the same equipment, sometimes you need to scale to the zero your scales and make sure that you don't have this important difference.
Even if they are using digital scales, to have them calibrated.
Yeah, that's very important. Okay, so
excuse me, I decided to put open my camera when I ask questions because it will be more like a sign for you. I have 2 questions from Kevin. He's asking, what about adding borax to water? Another question from Itai, who is asking, what of water from reverse osmosis?
Reverse osmosis. I think adding borax to water, no. If they are casting with stones, with diamonds, they will use a correct investment powder, which already has the correct amount of boric acid in the powder. So there's no need to add any more.
I think also people, there is this discussion, and we will have this discussion later on, where they put borax in order to strengthen the investment, or there is a saying like that, at least. But
it changes the chemistry.
Yeah, I agree. I mean, instead of that, we will speak later on about how to strengthen your investment without even anything else. You don't need to add anything. You just use deionized water and properly scale. What is very important, I think, is to mind the mixing time.
Yes.
Whether you mix with a vacuum mixer or a conventional mixing, these minutes are not just there just to give an idea. Because if you mix, let's say 2-3 minutes more or less, the chemistry will be different. So the whole process will be changed.
Exactly.
Last questions about mixing powders. Should I change the water powder ratios according to the humidity and the weather?
No.
That's also, we will maybe answer it later on, Tülay, because there is actually.
I'm going off.
Yeah, there is a. Let's go through a few slides and then we will get more questions. But there is actually the humidity. To remove the humidity, we have a process as well.
Yes.
So whether you are in a very humid country or less humid country or environment, you may use that process to make sure that the humidity is going up. So here is the process, but you can find it online on your website, Dave. So on your company website, and there are all the instructions for every powder, the mixing times, the way it should be mixed, and I think it's pretty straightforward. Is there anything here?
No.
Okay.
Explained everything now.
Now, one thing that we discussed earlier on is we mix and we settle down the flask, and during that settling, basically mixing and settling, the gypsum is expanding. But then what happens when you heat it? So you wait, let's say 2-3 hours on the ground, and then you put the flask in the oven. There are actually different expansion and shrinkage areas. That is, I think, very important and very interesting. First of all, the first phase between, let's say, 45-50 degrees up to 250 degrees. These are all in Celsius, so if there are some US attendees, they can convert it in Fahrenheit. But basically, you have this first stage where the gypsum is expanding. After, you have a high expansion side after, let's say, 250 up to 300 degrees, where the cristobalite element as well is expanding. So what happens is that you have the gypsum that was expanding, but now there is a very huge force of expansion due to the cristobalite component inside the gypsum, which after a while, actually, the gypsum is now shrinking. It's a reverse effect. And because the cristobalite expansion has ended, what happened? You see that expansion is going down. And then at around, let's say 450 degrees, 460 degrees, there is the quartz element that starts expanding. And I highlighted here a yellow area, which is basically the area which is not expanding. So that area is around 370 to 450 Celsius. That is, let's say, a safe zone that you like it, because you know that at that area, your basically flask or your investment will not be expanding or shrinking, right? And then you continue, you have still towards the end a gypsum shrinkage, let's say around 700 degrees. And when you stop, you low down your temperature to cast, then the whole investment is shrinking back. So this is why the curve is coming back towards down, right? Any comments on that, Dave or Dipen?
No, you've explained it perfectly. That is exactly what's happening inside the flask. That's how it gets its fired strength.
Yeah. So when we put it in the oven, what we should think is, depending on what happens to the heat and the forces, that this investment in the flask is expanding and shrinking non-stop. You have these movements basically happening. Now, yeah. Go on.
The way that the investment powder gains its strength is when it expands more than the metal flask that it's in. Yeah. So that's where it gets compression and the strength. Mm-hmm. So it expands more than the flask, and then when it cools down, it stays expanded higher than what the metal flask is.
Yeah, yeah. Typically, this range is like less than 1% in most of the investment, but I think it changes also depending on the quartz crystalline and gypsum ratios, right? Because not all investment has the same amounts in it.
No.
Yeah. So now we continue. I want to enter in what is happening when you do basically resin casting, because for the wax casting, you are, let's say, when you go to 80 degrees or so, things start melting. Then you have the carbon that is burning after a while. And in some cases, there is, the dewaxing process that traditionally was made for the wax type of investment or wax type of casting. But when you speak about resin, this is a totally different game. So there is a very interesting paper, and I will give all those references at the end as well, or you can ask us and we can send you all those papers, which is online. What they did is they compared what happens between some resins. These are not our own resins, but some other resins, and then wax. So here on the left-hand side, you have milled wax. On the top, the red one is the injection wax. All the others, they are resin. And on the bottom, you can see one known, resin. They also call it wax, but it's not wax, the project from 3D Systems. So they took all those samples and they fired up. Basically, they heated up. Now, what happens is when you are at 100 degrees on the top side, you can see that already the injection wax has melted, okay? It didn't disappear, it didn't fly off, but it has melted. But the whole resin parts are still there. The milled wax seems to be stronger as well, so it's still there. On the bottom, when you go to 177 degrees, let's say 350 Fahrenheit, there is no more wax that is not melted. So the milled wax and the injection wax is all melted, but you can still see the whole pieces of resin that remains there. Let's increase the heat a bit more. So at 200 degrees, now, okay, we don't see anything about wax. It's still, there is a black spot there, but the resins and the project part, what you can see is they become dark, and it's a sort of carbonification. So you can see that something has happened at 200 to 150 degrees. And if you look to some parts, some pieces, when you look at 275 degrees in those resins, you already see that there are some deformations that happen in the resin. So this can be due to expansion or change in the shape of the resin. Now let's continue. We are now at 375 degrees. As you can see, no sign of wax, but still these resins are there. And we push up to 700 degrees, which is quite high temperature. And you can see that those resins have ash remaining, and some of them may have more ash, some of them may have less ash, okay? So what happened here is that when you compare the casting between wax and resin, never think to the temperature and say, well, wax is melting at around 80 degrees. it's already melted. So if you have the tree of your investment, this is already melted. If you have your rings on your tree, these are already melted, then they are at the bottom. They are waiting, let's say. And when you increase to 200-300 degrees and even more, the wax is gonna fly off, okay? But for the resin, if you have a tree with the middle, which is wax, the middle is melting, but your rings are still in the cylinder. They are still not melted. They are still staying there. So I think that's very interesting to think about. And when we look to the most common issues with most resins on the market, what we can see is, first of all, you have a high content of ash. So even if you burn it at 700 or 800 or 900 degrees, you still have this ash component that stays in the resin. That's not the only problem, by the way. The other issues that most resins they have is that during the burnout, when the temperature is going high, the resin is reacting with the investment wall. So you have some reaction happening, and also the resin is expanding. So you have some movements happening. And this is a very, very important point to consider. So when you cast a resin, you need to know really how much it expands, which type of reactions you have with the investment, the content of ash, and so on inside. And just a note about the resin, I've seen in a lot of forums and a lot of users, they do from time to time post-curing of the resin to improve the casting. This is not something that you have to do with PowerCast resin, with our resin. We don't do any post-curing. But I just want to introduce another paper that shows what is the result about post-curing. By the way, any comments on that, Dave or Dipen? You are fine?
Yes,
It's okay, perfectly okay.
I don't want to, because we have a lot of slides and there's a quite heavy content, so let's go fast here. Okay, what happens if you post-cure some resins? Okay, this is another paper which is very interesting, and we can share it as well. So they took a very known resin in the market, and they did some casting test by post-curing 30 minutes, 1 hour, 2 hours, and they also did some heat curing. So they don't just post-cure, but they also leave it in the heat before making the tree, basically. And there are different tests there, they heat cure and so on. I just repeat, you don't need to do this for our resin. This is just a paper that, or for other resins that has been made, and let's see what are the results. So for that particular resin, what happened is that if they UV cured, you have the casting result, which is up. And if you have the heat cure, you have the casting on the bottom. Now, there is a slight improvement, but according to me, or to everybody, I guess, this is not really satisfactory. So what I am trying to say here is that if you post-cure or heat cure the resin, one resin, let's say, you may have some improvements that change the chemistry of that printed part, which may affect the reaction between the resin part and the investment in the burnout. But this may not be satisfactory, and the result may not be good enough, because your starting point, I think, is not really a good castable resin, or is not the right appropriate castable resin. Now, and I think one of the things we did, 4 years ago in our R&D department is we rethink the whole resin chemistry. So we have changed the whole thinking of how we should make a resin for 3D printers, thinking the whole process of the burnout, the investment used. And when you start looking at the chemistry, you have to change the basic. And that's why you don't need actually post-curing in our case. So let's see what happens if you use one of our castable resin. You have almost no content of ash. In some of them, you have a little bit of ash, but not so much. And that little bit, let's say 0.5, 0.3%, or very little amount, it's already removed during the burnout, because there is a sublimation process, which means that basically the pressure, when it goes from solid to gas, is removing that ash from the investment. You don't have any reaction with the investment. You have a very low expansion, and one thing which is important when you print is you don't need any post-curing. And our resin are able to disintegrate quite early in time, and after 500 Celsius, there is nothing that remains. So you know, I have some customers, they try to go up to 800 Celsius or more, thinking that if they go, let's say, to 800, 820 Celsius, during the process, they will remove the whole resin. But actually, you don't need that, at least with our resin, because after 500 degrees, everything is finished for the resin side, right? I mean, Dipen, you have a lot of customers in Dubai using our resin, so.
Yes, it's a blessing for us, believe me, when they are using your resin. So we have a lot of issues solved at the preliminary levels, you know. So continue.
One thing I want to say is, okay, now we know wax is different, resin is different. And one thing that I receive a lot of questions is, okay, how much wax there is in your resin, you know, is it melting and all this? But the chemistry of resin, not only our resin, but any resin on the market, is a polymer that is basically polymerization using UV. So even if you have a lot of wax in it, this doesn't mean that it will melt like wax, because it's a thermoset polymer, sorry. And the links are so much crossed that whatever you do, it's not going to be melting like wax. What you need to consider is use resin that will have a good casting, that has an early disintegration, low expansion, so that when it stays in the flask, it doesn't shake the flask. It doesn't, you know, it stays there, and when it becomes from solid to gas state, it disappears. That's the most important. And because wax casting, and I think there is a question, let me finish that, right?
Yes.
Wax casting and resin casting is different. So when you cast resin, I would strongly recommend to be more careful on the process, like the mixing and so on, because wax is melting at 80 degrees. Whether you put a bit more water or a bit less water, or if you mix a bit more or less, will not affect a lot maybe your final casting. But in the case of the resin, because the resin parts remains in the investment and they disappear after 300 to 450 degrees, it's important that, you know, you do it properly, let's say, and try to get a stronger investment. Okay, that's good for the question.
Yes, Stefan is asking, what about some air injection?
Is this, you tend to find that some people will use an air gun. They take the flask out of the furnace and then they blast the flask with air. It's not advisable because you're firing cold air into a hot flask. You can get it makes the mold crack.
I think they do this trying to remove the ash remaining from those resin parts. And the problem is, you know, I don't know if Stefan tried to burn out something like a resin part at 800 degrees, but if you burn it out, what happens is that the ash during the burnout react with the investment, and that piece of ash stays on the wall of the investment. So the air that you are going to put inside will maybe, you know, will not remove that ash so easily. So I don't think it's advisable.
No.
Better start with a low ash content or no ash content resin at the beginning. By the way, this is, for example, a slide I have here, which is interesting. So we took another resin and we took one of our castable resin, and we printed a big part and we put it in, you know, in the investment. We did our burnout cycle, and due to the expansion phenomenon that happens in the investment of that resin, you can see that the whole part on the left, the whole details, the investment has all cracked and it has been broken. While on the right side, you can see that you have a clean burnout. So that's the difference between, let's say, a good resin and another resin. So there are a lot of resins on the market. They say it's castable, but according to what, I really don't know when you look to the details. And let's see. Another point about the expansion of the resin. This is another paper. I think we have it in the reference. It's kind of quite old, maybe 10 years old. Maybe some of you know the 3D Systems Viper machines, and they use this resin. Now, because the resin is expanding in that case, what happens is that you can see on the figure 16 some large metal positive areas that has been created because the the ring has expanded during the burnout. So while expanding, it cracked that area of the investment, and obviously that investment is gone. So instead of that investment, now you have metal taking place. So this kind of issues is really related to the expansion of the resin. So you need a low expansion resin. Yeah. Okay. Now we are going to the hot topics, I think. And any comments until now?
No, it's okay.
It's good.
Okay. Now, I receive maybe every week, different questions from customers. What burnout shall we use? We have put officially also in our website, like PowerResins.com, and in our team are giving a lot of advice to our customers. First of all, people think that everything is about burnout. First, I think burnout is important for the investment, definitely, very, very important. Burnout is also important if you know what's happening in your resin, so that you can, according to the resin, adjust your burnout. Now, and it's also important for the strength of your investment, which is important for your casting. So I just want here to speak a bit about the logic of when you choose a burnout, what to look after. So first of all, as I mentioned, if your investment is weak, what is going to happen, depending on all those expansion movements that are happening between the resin and the investment, you will have some resin breakage, like these cases. So here on the left, and usually you see these kind of things on the engravings, right? I mean, Dipen, maybe you have some experience as well on that.
Yes, true.
And so the first thing that we want, ideally, is to have a strong investment. Now, I know, Dave, you have a new product, which is very interesting, and some other investments. So as investment manufacturer, there are differences in investment about the strength, right?
Oh, for sure, yeah. Depending on the cristobalite content, quartz content, and the quality also.
Yeah.
Quality of the cristobalite. It's okay having an investment powder that has 50% cristobalite, but if the quality is no good, then
no use.
So one thing is the raw material. Let's say you have investment, different brands, different quality of products, which affects a lot the strength of the investment. And the other thing is there are some tricks or things you can do to strengthen your investment. So let's go through a few things after on how to strengthen. Hi, Tilay. Question is coming.
Here again. Yeah, it's about strengthening the investment because Mr. Pretty is asking how much time we should keep the investment out before we put in oven.
Yes, we will be speaking about that in the next slide.
Yeah.
Okay.
And okay, just about that, what I want to say is, maybe Dave, you want to say something about it? You recommend, I think, 90 to 120 minutes or more?
Yeah, we recommend a minimum of 90 minutes.
Okay.
After investing, it's left undisturbed for 90 minutes.
You're on the same ground, I guess.
Yes, I think there is no shortcut on that. People try to make it short of that immediate to invest and then put it into the burn-off furnace. Yeah. It's a very big mistake that they do.
I think there are a couple of papers where 2 hours is a good time, but 3 is slightly even better. But 90 minutes is definitely the minimum. I mean, if you don't leave it 1.5 hours, then you have like really serious issues that can come out about the strength.
Yeah, for sure. The investment powder isn't gaining its green strength in time.
Yeah,
it isn't expanding. There's no compression. 90 minutes minimum.
Yes.
Yeah. Now, I just have these slides for our customers when they cast PowerResins, what they need to think about. So there is a low expansion of the resin. So we want an investment that is strong, but if we look at the resin side of it, we want it to be strong below, let's say, 300 degrees. It doesn't really matter if it's strong at 700 degrees because there is no more resin anymore in it. So you want it strong when the resin is burning out, right? And we know that the largest disintegration period is around like 300 to 450 degrees, but it already starts also before. So what is important is to have a strength at the low low temperature, and after 500 all is gone. So we don't need to heat up to 780 or 800 degrees the oven.
No.
In our case.
No, but for the investment powder, you have to go to 730 to get the expansion and get the full strength.
Yeah, 730 is a good. I think it's pretty standard as well. You're right, Dave. And in those slides, I put 750 to make it simple. But is there any issues about difference between 750, 730?
When it's that high of a temperature, 20 degrees is not a big issue.
Okay. So we want to have a strong investment. How do we do that? So first, you mix your investment and you leave it at least, in my opinion, 2 hours, but minimum 90 minutes, and ideally between 2 to 3 hours on the ground. You don't put it in the oven because it needs to lose its humidity to form to have all the expansion happening, and you wait. You wait 3 hours. Then there is a very interesting paper that what they did is they basically tested different burnouts, and one of them had a step of 100 degrees. So at 100 degrees Celsius, the water is not boiling yet inside the investment. If you put to an oven at 100 degrees, because the middle is much less in terms of temperature, it will not boil. But what happens is that it will remove the humidity. So in that interesting paper, they put the investment in at 100 degrees, 2 hours, 3 hours. They make a step like that. And then they increase the temperature. So the next step you want to do is to remove the water from the investment. So you can use 150, you can use 220 degrees, or whatever the investment manufacturer is recommending you, right? Because you also, on that, when you are at the step of removing the water, I don't know if you agree with me, but if you go to very, very high temperature to remove the water, and we will see that in the next slide, you may increase the pressure of the water basically boiling. So if you have high pressure, it may also break the walls of the investment, right?
Yes. Exactly. When it condenses, you're creating a steam, which is creating a pressure.
Yeah. Then you remember there was this safe zone between 370 and 450 degrees, which is like the investment is not basically expanding. That's also a good thing because this is where basically most of the resin, our resin, is disappearing. So you can use that safe zone as a step and leave the investment there. And then you can go to 730 or 750 and then finish your casting, right? Yeah. I think just to understand what's going on, between the theory and what's in the reality. So let's say you have a burnout, you put the first step and you say, I will increase it so much that there will be a lot of water removed very quickly, and let me go to 270 degrees as the level, the first step. What you can see on the left-hand side is the theoretical curve, and on the bottom, which is rounded, the red part, is what's happening inside the flask and in two different regions, the bottom of the flask and the middle of the flask. So, even if you go to 500 degrees or to 270 degrees or whatever temperature you program your oven, what happens is that inside your flask, you have water. That water boils at 100 degrees, right? And while it's boiling, until the whole water has been removed, the temperature inside the flask cannot go above, let's say, 120 degrees. It's very, very difficult, right? So there is this lag between what you think will happen to your burnout and what really happens, because of the boiling of the water, you have this step where you stay at the 100 degrees Celsius elements. Once the whole water is gone, then you increase. Dipen, do you have any comments?
Yes, it's okay. Perfect. It's like this.
I think at this point, what is important is to have, and by the way, even if you have the best oven in the world, that's what is going to happen. Because
this is exactly what happens. We've done we do these tests weekly on all investment powders of our research team and research and development team, and it doesn't matter how high you go, that until all that water All the moisture's gone out the flask. That flask will not reach above 100 degrees.
Yeah. And let's imagine the case where you didn't wait outside, right? You just mixed, pour it, wait, let's say 10, 20
10 minutes.
minutes, and then put it inside. That thing has a lot of water, a lot of humidity inside.
Oh,
You put it. So what happens? You put it at 300 degrees, the first step, let's say, or 250 degrees. And then with the heat, which comes from outside of the investment towards the inside, because your oven is heating from outside. So the walls start boiling. The pressure evaporation goes through inside. And on the wall of the cavities inside, what happens is that you have breakage happening, like some ships going, right? Yeah. So the more faster you do this first step, you may have more pressure in the evaporation. Exactly. But even if you do it very fast, that flask will still remain at 100, 120 degrees, whatever you do. Right?
Yep.
Okay. The other interesting thing on the right-hand side there is, as you can see, even if you cut your burnout, let's say you go from 700 degrees to I don't see it well, but to 450 degrees, yeah. Due to the hysteresis and due to the fact that the investment is like an insulator of heat. In other words, it's not metal inside the investment. If you reach a certain temperature inside the investment, that is it takes time also to reduce. You cannot just switch off your oven and say, okay, now I go back to 500 degrees. You cannot do that. Right?
No, that's why we say once you come down to your casting temperature, always wait a minimum 1 hour.
Yes.
Yeah. The center, the core of the flask, then is harmonizing with the temperature that you've set it to. If they've set it 600, you need wait. As soon as the digital readout reads 600, it doesn't mean the core of the flask is at 600 degrees. The core of the flask may still be at 700, 720. That's why we wait a minimum 1 hour.
Yeah. Yes. So you need to wait so that slowly the heat goes down. Because at the end, what matters for you is the inside of the flask, because that's where your metal is going to enter. Yes. I mean, you don't care about the outside of the investment. Okay, so this is just a note about what is really happening and what you think is happening, let's say. So here I put just a recommended burnout, but again, please take all those burnouts according to your investment powder. So the first thing I always say is, okay, at least with our resin, because we know that it's very easy to cast, first follow properly the whole steps of the investment recommendation. So this is the first step I recommend. Check the mixing time, the temperature, the burnout that the manufacturer of the investment is providing you. This is the first step. And at least it gives you a reference. So if you want then to try different burnouts, at least you have the reference, the benchmark, saying that you have this is what happens from what the manufacturing is telling you. And trust me, if you follow what the manufacturing is telling you and you have proper investment, 99% of the case, or let's say 90% of the case, you will have very good casting, at least with our resin. I mean, Dipen, maybe you have a word on your experience in the Dubai area and in India.
Yeah, sure. Because what I think manufacturers put a lot of efforts to define those processes and the temperature and other things. It's not just like they just put the numbers, but they have done a lot of practices, a lot of tests, and then they put this number. So please follow that numbers, what they are suggesting. Yeah. That is the best results.
So this is a standard burnout that we can recommend. Now, I wrote there, hold 3 hours before the oven. So you leave outside 3 hours. You put it in the oven, you go to 150 degrees, you hold for 3 hours. Actually, what happens inside your flask doesn't go to 150. It stays around 100 degrees because the water is boiling, right? So you are at 100, 110 degrees, but you leave it enough long that the water is evaporating. That first step can be 200, can be 220, depending on different investment. Then you go to this other safe zone. The second step is where you want to burn the resin. So 150 is not enough. We have seen it. It's enough for the wax to melt, but it's not enough for the resin to disappear. So, oops, okay, we have some. So the second step is you ramp up to 450. And at that ramping up, you don't want sometimes, I mean, at least on this schedule, you don't want to ramp up too fast.
Yes.
Because
all of our investment powders, the ramp is at 150 degrees. That is the optimum ramp.
Yeah,
ramp
per hour.
rate.
Yeah. So 150 degrees Celsius per hour. That's
Yes.
pretty much what you're saying. Okay. So we ramp it up to 450. Then we leave it there 2 hours because we need to remove the whole resin. Okay. Then we have to continue the expansion and the whole process of the investment strength. So we go to 730 or 750. And this is where we leave it. Let's say, what do you recommend, Dave? 4 hours, 3 hours?
4 hours.
4
Yeah,
hours.
3-4 hours.
Yeah. That's where you also have the quartz element, right? You have
Yes.
the quartz element that add also the strength, I guess, with the
Yeah,
crystallite.
it's keeping bonding.
And then you reduce for your casting temperature. Okay, we can speak about casting temperature, but casting temperature also depends on the type of the model, on your metal, on a lot of things. So we will see some issues in few slides where we can speak about the casting temperature as well. And you want to do that last stage at least in 1 hour so that the inside of your flask gets that temperature.
Yes.
Yeah. I have here another recommendation is, and I think depends, some of your customers may use that as well, is
Yes. Yes.
we left it 3 hours outside. We put it in the oven, but we don't go at 150 degrees or 200 degrees. We leave it at 100 degrees for 3 hours. We do that because we want to remove the whole humidity. And we know that if we do that, the strength of the investment will be stronger than if I don't do it, right? I don't know. Do you have a lot of customers doing that? Because this is not very common.
Even on the people who are doing in the overnight, putting the flask in the oven, so they want to make sure the use of the whole the time. So there is the best time, they use it the longer the time when they close the factory. So 3 hours they keep it out on a certain temperature, like say 80, 100 degrees, and then they slowly move up. So make sure the moisture completely or the water completely dried. There is nothing. So a lot of people are putting this. The people who are doing in the day casting, they are always in the hurry. So it's a different scenario, as you know.
Yeah, that's correct. And then you can go to, let's say, a step where you boil your water, 150 in this case, what can be 200 or whatsoever, because you already have an investment with very little humidity. So it will be easier also to ramp up, and the water remaining will be removed. And then you have your 370, 450 zone, which is fine. And then you go to the 750 or 730, which, by the way, I've seen a comment which came to me, when you use, let's say, stones or diamonds, I think the last stage, the highest temperature, it may be slightly lower, right? I don't know if you
have... Yes, Dave, you can tell.
30 degrees.
630.
Yeah, but when you're using with diamonds, they will have the investment powder has the boric acid, which is there to protect the diamonds, but also it gives the strength, a lot of strength. The only issue you then have using the stone and place powder is the clean off is a lot harder.
Yeah, that's true. I mean, I think you need to mind your temperature with the stones, as you mentioned.
Yes.
So, that's a different.
Only for diamonds.
Diamonds, yes, that's correct.
CZs, they can use Protocast.
Okay, very good. Okay, let's continue. So now, just to compare, this was our slide. So we have a lot of steps here, and it's quite a long burnout. Here we see like 17 hours, 18 hours of burnout. What happens if you remove the step of 150 degrees? Now, you remember what we shown before, where even though I go very much high at 450, inside the flask it still remains at 120, 100 degrees because the water is evaporating, and then it will go up. So it can be done. I would say it is a possibility, but it's experimental.
Yes.
What is your comments on that, Dave?
It's experimental because removing that step of between 150 and 220, that is a critical step for the investment powder.
Yeah. And also,
but it's not to say that it doesn't work. We've seen it working in other places. I've been with Dipen where we've seen it working in places.
it may depend. I mean, this cannot be maybe a recommendation we can do for all investments, but in some cases, I think I've seen it working as well, and I've seen even different. We will see in the next slide. Directly ramping up, that works as well, in some cases. From the resin perspective, there is no issue of doing that. You can do that because the temperature, like from 100 to 450 degrees, at least for our resin, we have low expansion, so there's no major issue. For other resins, you may have issues in doing that, I think. But as long as you stay, once you arrive to 500 degrees, everything is gone. So, whether you go it in a fast way or you do a lot of steps, the step of 150 degrees doesn't change anything for the resin. That's what I meant. But the step of 100 degrees is interesting to make the investment stronger. That's, I think, important for the resin. So, okay, you can even make it shorter or directly heat up your oven at 750 or 800 degrees and just put your flask in. So I have seen this doing it. I have seen that type of burnout. Again, these are experimental, and sometimes it works very well. Sometimes you have other issues. Hi, Tülay. Some questions?
Hi again. Yeah, we are almost coming to the shorter cycle. I got some questions about short cycles, but we are coming there. Before it, how long should I leave flask at casting temperature before I cast? Because some say inside of flask is hotter than outside.
Minimum 1 hour.
No. In the furnaces, you have to keep the 1 hour. Immediately when you take out from the furnace, you can go directly for the casting because you are sure that the flask is at the right temperature when the burnout is showing good or the precise temperature.
The one thing about the investment powder, Tülay, is it also holds heat very well on the inside. So one of the tests that we do when we create a new recipe is we will take a flask out of the furnace with a filigree item in, and we will leave it for different times, 5 minutes, 10 minutes, 15 minutes from the furnace before it goes into the casting machine to cast. And there's not a great deal of difference in the casting because the casting, the investment powder holds the heat very well.
Okay, cool.
So as long as they leave 1 hour from going from the top temperature to casting temperature, as soon as they take it out, straight into the casting machine and cast.
Okay, great. And can we keep the investment for 3 hours inside the furnace at 30 degrees for cooling for drying?
Then you can, with many of the programmers now for furnaces, you can put a delay on. So if the furnace is at room temperature, 20-30 degrees, delay the burnout. So if it's delayed for 180 minutes, it's not going to kick in for 3 hours. So yeah, perfect.
Okay, last question. Is there any difference between 18 karat, 21 karat for burnout?
No, there's no difference in the. We have investment powders. We have investment powders for casting brass. We have investment powders for casting all types of white and yellow gold, and the burnout is exactly the same.
Palladium may be different, I guess.
No,
palladium as well. You use the
same burnout.
And
only the casting temperature is different.
It's the casting temperature that's different.
Yeah, the casting temperature.
Yes, but the burnout cycle is exactly the same.
Sure. Okay, so let's summarize what burnout is it helps basically the investment to strengthen the chemical change in the investment, and it helps also to remove whether it's wax or resin from inside. So once you have that cavity which is strong enough, which has already, let's say, like a stone, and that has the right chemistry, whether you put inside silver or gold or whatever you put inside, it's same, right? That's my understanding.
Yes.
Sorry, I said last question, but I would like to ask two more.
Sure.
One is a very frequently asked question, which is, what about to turn flask upside down in the oven?
No. Every furnace has most furnaces actually have a very good air circulation, so there's no need. I think it's more of a myth to turn the flask upside down. Many people believe it removes the gases. No, it does nothing.
Actually, this is a good one. We have in our R&D department an oven, and we do a lot of tests, and we did this actually. We put it up, down, sided, and everything. Whatever you do, when you break the investment and you open it, if obviously the resin has the proper, let's say, one of our resin, you don't see anything. So whether you put it down, and the reason for that, I think, is because if we speak about resin, and I think for wax as well is true, at least for resin, what happens is you go from a solid state to a gaseous state. So people always think that this thing is melting, the resin part is melting, stays there, and then it flies. No. These things from a solid becomes air. So it goes. And when it does that, whether you turn it up or down, it will flow from everywhere. So if you have a proper burnout, if you have a proper resin, you will not, by the way, even if you don't have a proper burnout or resin, it will not make any difference. That's my point. And I agree with that. I mean, at least from what we have seen. Okay, any other questions?
Okay. Yeah, I have many questions, but I choose some of them. I keep them for the end of the webinar. Yeah, but last question is if wax and resin should or should not be in the same flask.
Yes, you could in theory, but it depends. Yeah. Go ahead, guys. Your comments.
Okay.
You go first, Dipen.
Okay, I think
I go.
Yes, okay, because of the wax and resin, people put it all together because some of the resins, they require very high temperature to burn out. So they go even maybe 730, 750, not PowerResins I'm talking about, but the some. So because they want to remove completely that ashish, so they put it out both together and then do first the wax casting. So that is finished, which is the very less temperature also. Then they go very higher up to the resin casting temperature, let's say 750, 780 or more. And then they come back again to the casting temperature. This I have seen it in many customers doing it because the resins are not good enough to burn out completely ashes. They want to make sure that they go higher and then they finish it up. So they put it out both together, but then they have to play with the casting cycles, both together. They can, but we recommend better to keep both separate is the best.
Yourself, Dave?
Yeah, exactly what Dipen says. I visited many customers that will have waxes, resins, different types of resins, all on one tree. There's many customers that they don't print themselves. They are just a casting shop where the prints are sent. Very similar how it's set up in Turkey. Yeah. Most of the companies in Turkey, they don't print, they don't wax inject. They have everything sent to them. They will put everything on one tree and cast.
Yeah, I agree with that. I mean, you can mix pretty much most of the, let's say, wax with resin. The only thing that I see, and I have seen that, if you have very large part of a resin that has big expansion, and you put it, it may crack your some walls of your investment in that area. But most of our parts are very light jewelry and light parts. So in whether you use our resin or another, you can put with wax. I think that's safe to say. So okay, we will be speaking about some casting issues and solution. Let's go through some slides, and then we can move on to to the questions. One thing that we see a lot, we see not a lot, but we see quite often in some areas where, by the way, those manufacturers, they want to have very light jewelry. So whether they use very tiny filigrees is what I call the partially filled. So you have this bangle or this ring, and a part of the metal didn't enter to that area. So this happens most of the time when you have very tiny strings. Like in that picture, the strings is from one of our 3D printer, and I think it's around 0.25 millimeters. And the left-hand side, I don't know exactly, but probably around 0.25 or 0.30 millimeter. So the metal didn't enter in that areas, and you have this partially filled. You can see that as well in very thin surfaces. So same here, the surface I think is around 0.26 or 0.27, and because you have a big part, the metal didn't enter. Now, how do we overcome this problem? for that, I want to make it very basic. It's very simple, in my opinion, but please comment after it. So I see gold, the metal, or silver. It's basically, when you melt it, is a liquid, right? So if you increase the temperature, it will be more liquidified. And what you are trying to do is to put some metal that is very hot inside the flask that you think it's hot. It's, let's say, 700 degrees or 600 degrees. But there is a big difference between the metal temperature and the flask temperature. So it's like pouring something very hot on a very cold surface. What happens? It solidifies. So when you put the metal to the flask, I think what is the most important thing is the difference in temperature between the flask and the metal. If you have a very high temperature difference, in other words, if your flask is too cold, or your metal is too cold because it's solid, when you put it in, the solidification will start quite quickly, and the metal will not be liquid enough to go through those details, right? Depend on that. Any comments?
Yes. Okay. Sometimes, as we see also some of the alloys or the metal, when you increase the temperature, it reacts more. So some of the, we will see also in the next slide, some casting machine. Some casting machines also have the good feature that they can control it, the solidification time. That means when you pour the gold or metal into the flask, before it starts to solidify, it is more seconds more, some 10, 15 seconds more, sprayed as a liquid. So that you can control it in many casting machines. So some of the problems you can solve it in that.
We will speak about casting machines, and I think this is very important, the machine and equipment you are using, because there obviously there is also the pressure difference, the speed at which you put this metal inside the flask. If you go very fast, the metal will still remain liquid and go through those details. But if you go very slow, then it will solidify and it will not go through those details, right?
But one of the biggest things that you've got on your slide, but we haven't mentioned yet, is the feed, the sprue.
Yeah, that's correct.
If the sprue is not sufficient, if the feed is not sufficient for the part, then if the sprue is very thin, if the sprue is very thin, it's going to cool. If it's going to cool, it's going to be and set, and then none of the liquid metal coming after can then enter and fill your parts. So the feed is also very important.
I agree. I mean, let's say on the left-hand side, this bangle or the part on the left-hand side where there is the big hole, if you put a feed in the middle of that filigree, obviously the metal will be also entering from that area and will fill it. So that's definitely. So if you don't have big pressure, or if you're not, if you have issues with your casting machines and other things, but in general, anyway, you need to check always your feeding. I mean, your cast.
And also the correct investment powder.
Yes.
With the correct investment powder, it will have the correct permeability to allow to allow the alloy to flow in the flask.
Yeah, there is an example which we will speak later on, but people should understand, I mean, manufacturers should understand that the investment powder that is cooked in the burnout actually has, it's like a sponge, right? So it has some permeability, not as much as a sponge. It's a stone with some permeability. So if the permeability is good in that investment, when you have this pressure difference, the vacuum effect will be more sufficient or more efficient than if you have a stone that doesn't have any permeability, right? That's what you mentioned, Dave?
Mm-hmm. Yeah, for sure.
Okay, so just want to, please go ahead if you have any comments.
No.
Okay, one thing is, most of the largest manufacturers, they all use proper, let's say, vacuum casting, but I know that in US or even in some countries, and we did ourselves as well in our R&D, some centrifuge casting. So when you want to, if you have a centrifuge casting, what you can do is you increase your centrifugal force. Basically, you turn it faster. I mean, if you have a higher speed, you will have higher pressure. For vacuum casting, you do that with your casting machine, and you need to have a proper casting machine.
Yes.
Another suggestion that I've seen in one of those papers, and it's not very much common in the market, but it's about the permeability of the investment. So a way to increase that is to put more water. So what they did is they put a lot of water. The ratio is 42 to 100, and by doing that, they could increase by 30% the permeability of the investment. So it becomes more like a sponge. So which means your vacuum would work better. But if you do that, it may help, but actually be careful, because when you increase the water, and we will see in the next slides, you will have issues with the surface. So playing with the water powder ratio is risky, right? Any comments on that?
Very risky. As you've said here, weak investment, you'll end up with flashing, rough surface. The correct investment powder gives you the correct permeability to start with.
Yeah. So first of all, if you put too much water, you will have some rough casting surfaces, and also your investment will be weaker. So you remember we said we want a strong investment, which is good for the resin, for the whole expansion part of it. So if you don't leave your flask enough on the ground, at least 2 hours before putting in the oven, or if you don't, or you may use also that step of 100 in the oven to remove this humidity, your investment will not be strong enough. So there are these are the issues seen on the rough casting, but I will give some examples here. So let's say we play with the water. That's on the left-hand side, one paper, which is also in the reference. It's interesting. They played with the water powder ratio. It's a very standard investment. I don't think it would have this result in some more professional investment. But anyway, it shows the result. On the left-hand side, you have much lower water. On the right-hand side, you have more water. What happens is that when the water is evaporating inside the flask, if you have more water will be removed from the surface, and this basically gives you this surface, which are granular surface like that, and we can see it also on the right hand side. And because your investment is weaker, when the water will be removed, it will basically remove some chips and flakes inside the investment, right? This is called spalling, also very common. You can see that in wax or in resin, and I think it's due to the pressure happening if you remove the water too fast, that those chips and flakes are entering in the investment. The walls are contaminated from the pressure of the water boiling, right? Dave or Dipen, any comments on that?
Yes.
No.
Yes. It's okay. Perfect. Like this.
Perfect. If you heat up too fast, you're creating a pressure, and it has to release, and it will release on a flat surface.
Yeah, and that released part of the investments remains in the flask, and when you pour the metal, that gives you this negative offset on the surface, which is something you don't want. And we hate that because it's very difficult then to polish and to fix it. Which, by the way, this happens now. People tend to say, this doesn't happen on wax, or it doesn't happen on that. But as I mentioned earlier, the process of resin and wax are different. So you need to consider the steps, and you need to consider the speed that happening. So in our resin, we don't see a lot of those issues. If you follow properly the instructions, you will not see this happening.
But go back. That issue does happen with wax also.
Yeah, that's correct.
If they put the flask in the furnace too soon, it's not been stood for 90 minutes. If they ramp up 300 degrees per hour, they're going to get this issue whether they use wax or they use your resin.
Yeah, but Dave, sometimes what happens is in some, not most customers, but some customers, because they just start doing resin casting, they see these issues and they think that it's only resin related.
No.
Yeah.
At the end, it's very difficult for resin manufacturer to explain that it happens also in wax, and please follow the instructions. And we help them a lot, actually. We do some trials together, and Dipen, with your customers as well, we have worked very nicely.
Yeah. That's why the three combination is must: resin people, investments, and the casting. We spend the three people. then you have a best results, you know.
So, Dipen, I want to have a few words about the importance of the casting machine, because most of our customers, I mean, in the world, manufacturers, they use vacuum casting, and there are a lot of brands. And I'm not a manufacturer of casting machines, but in exhibitions or when we visit, they always ask me, what is the good casting machine? What do you think about that brand, that brand? And as you know, we recommend some casting machines, but you are better suited for that.
Yes.
Please give us some, what matters in the casting machine.
Okay. When you follow the process, which just now explained, then your 50% or 60% work is done. Because when you cook well, then your work is done. Then it doesn't matter too much that which casting machine you are using. Okay, of course, we have to use it high-end vacuum pressure casting machines to get the good results, what are things. But when you cook well, you get the good result. But still, there are some things, like as we all know, there are good casting machines manufacturer in the world. You can count on the fingers. There are, we have because we are 15 years working with the Topcast, so we have a very much experience of machine itself, and also we are working with many different kind of customers that using a lot of different investment, resin, wax, the different designs. So we have a lot of experience, a lot of exposures for this, and based on that, we have a good suggestions for them, all the processes. Now, what is required? Important of the casting machine, as you know, the machine must to have a good parameter controls. Like as I told you also before, that it must to have some of the parameters, say how you can control of the solidification time, so you can increase and then you can fill up the unfillable parts. So a lot of problems which you have already made it in the burning or other things, you can justify that in the casting machines when you have a good controlled casting machines. Then it must to have a good gas purging, because when you load the metal and when you close the chamber, there are a lot of oxygen is there. So machine must to have a good vacuum system on the top. The filters and the vacuum must to have, because you don't need this oxygen with the metal to melt.
Yeah,
because that is creating a oxidation process and a lot of things. So you must to have the good vacuum, and then you put it out the argon gas or whatever the protective gas is there as per your machine. It must then. So melting should be in the proper gas only.
Yeah.
So that all the melting is proper, and then the homogenization, because oxidation is the biggest enemy for the metal when they melt it and other things. Of course, you must to have a good machine which is between the melting chamber and also the flask chamber. This two chamber is very important. Okay, physically we see it, there are two chambers. Every machine has two chambers. One is the melting and thing. But as a functionally, when you see it, both are operating as a single chamber, like most of the machines. In Topcast, we have a double chamber systems. Why? Because we have a very good sealing of that. What is the meaning of that sealing? So when you melt it something and then you put it out the flask in that, both these chamber are acting completely independently. So when you increase something here, or it doesn't go, or some of the investment powder, when you take it out from the burnout furnace, you see a lot of gases is coming because of the sulfur dioxide, we call it. And this gas, when you put it out in the machine and your casting process is happening, these gases need to remove, because otherwise, what is happening, when you open the stopper rod and the metal is going, this gases goes up, and it is restricting the flow of the metal, and which is then you have to use it a lot of other pressure and blah 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 other things. So you must have a good vacuum and independent chamber, so you remove this all the gases and a vacuum. We have in the machine, because we are very much useful of the Topcast machine. We know that this the bottom chamber, we are not doing vacuuming from outside of the flask. Most of the machines, they use the outside the vacuuming, so they have to continuously vacuuming and put in the protective gas. This is then it is the lot of dependent, as we are discussing about the permeability of the investment powder. If the investment powder doesn't have the good permeability, this doesn't go. We are not facing this problem because we have a very good vacuum system on the bottom, which is doing from inside. So you have like space, you have all empty. And when the metal is going in, you have nothing to restrict that metal. So you can easily flow this any your filigree part, or without increasing the temperature or without increasing a lot of pressure, because sometimes you increase pressure, if the investment is not good, it breaks, So there are a lot of things. So you choose is very, these are the old double chamber systems. Then
I want to just add one thing. I think, we are selling 3D printers and you are obviously selling casting machines. One thing I always say to my, to my colleagues and to everybody, actually, we are not selling a 3D printer, we are selling resin, 3D printer, but what we are selling is a service and knowledge sharing, a partnership. So I think for the casting machine, it's quite technical. And you explained it very well, by the way. I mean, I know, because we have seen in some customers the differences in different casting machines. But what I feel is the most important is what the customer wants. They want to have the proper result. And to get that, they need a proper partner. So they need a well-known brand, but not only the brand, but in your market, somebody that can, and we have been in many customers together, somebody that can really act as a partner and can help implementing the perfect solution, right? I don't know what.
Yes, it's like this. All the machines are good because the manufacturer made the machines to work. They don't make the machines that doesn't work. They have put a lot of efforts on there. You need to as we selecting, when you want to choose which is the right partner, after selecting the machine, you have to look what is the casting machine is in the market is doing your jewelry type, what you want to make it, is exactly already doing it or not. And the second most important part, the partner which is selling the machine, how is he knowledgeable? What is he focused, or is just I call it a supermarket?
Is he just buying or selling, or is interested in the casting process and helping you to?
Because if it is the focused only on the machine and the process, then you are rest assured that you have a good installation and then good maintenance, and then of course the people are doing everyday new designs, new things, new experimenting. So you must need a partner which has the knowledge and the skill that can solve your future problems also. It's not just to install one time, you install and then you forget. Because machines maker are not every day coming to.
Hello.
So you choose the right partner. Then last but not the least, I have seen a lot of casting problems, a lot of other things, because they are using example for the, let's say, crucibles or the stopper or the thermocouple and other things, just to save some money. Because it is other people are selling, but they don't know what is the technicality behind them of few dimensional difference or other things. So I would recommend better to go as the authorized agent to buy, even if little bit of costly, but that is overall is the cheaper to you.
I agree. When you try to cut the cost on, let's say, the materials and so on, then you may have other issues at the end that is costing you much more, actually, particularly in the gold industry. I mean, that's the case. Dave, sorry, Dipen, do you have any?
No, it's okay. I was asking Dave to comment anything on that.
On the casting machine, Dave, do you have any comments?
Exactly what you've said. Always use the reputable companies. It's okay buying a cheaper machine, but they don't seem to have the service and the technology in the machines, it's only copied. So use your reputable companies, use the ones that are around in your market.
And I see, the casting as a process, there is the investment side of it, the casting machine, the resin and everything. It is actually the most important process of a manufacturer. You have your marketing and sales guys that have to sell the gold, and at the end, but at the end of the day, for a factory, I visited quite a lot of factories. Some factories, they think that casting is a secondary, it's a remote place where things happens, but you don't invest a lot of money in it. But in my opinion, this is a very scientific process, and you need to follow the instructions scientifically to have proper checks, to have proper parameters, and to be able to make science, you need proper equipments, and that's one of them. I think it's the casting machines. Okay, I want to speak about the investment here. You have launched a new product, Dave, which you have tested it with some of our resin.
Yes, yeah.
Please, you might like to comment some of those pictures because
Yeah.
they are very big zoom, 50x high resolution.
Yeah. So the 50 times zoom. Yeah. So Protocast, we launched it at the Vicenza Aura in January. We've tested this product in all of our factories around the world. We have 7 factories around the world. Before we launched it to the market, before we sent it to the market, I went to Turkey for testing this product. I've sent it to India, to Dubai, and we're getting good results back, good feedback. These are your resin models that I took from you in the Dubai exhibition.
Yeah, I remember.
We invested them. As you can see, 50 times zoom, very good for your stone settings, very good for your surface finish.
Yeah, that's because the pictures are very high. Actually, it's funny because you can see the layers on the prongs of the 3D printer, and this is 50 micron layers, so we can also print at 25 micron. But just to give you an idea of how scaled is that picture, so you can really see the cleanness of that casting in black and white. You used a special camera to take these pictures, I think.
Yeah, our digital microscope, yes.
Yeah. So, okay, I think we can wrap up. Here we have basically all our contact details. What we have put here is, okay, Novafab is our brand for our 3D printer. PowerResin is our resin brand. You can contact us via WhatsApp from these numbers, and you can see our website and so on. Dipen, you have 2 companies, one in Dubai and one in India. So these are the details of your both companies in Mumbai and in Dubai.
Yes.
And people, if they have any questions about casting machines or casting technologies, they can join you. And Dave, these are your contact details. You are in the UK. So now I think today we can go with some questions and answers.
Yeah, I have many questions. Mr. Harish is asking, any recommended vacuum pump with particular CFM for lightweight jewelry?
For the casting machine or the investment mixer?
I think this is maybe for the casting machine.
Yes.
Casting machine, you go for the manufacturer. What they are giving is the best because they have tried and tested a lot. There is no need to change any other vacuum pump because it is they have not only the installation of what particular city, but they have all over the world. So they are experienced with that. If you have a problem with the vacuum pump, go for the same vacuum pump for the machine.
I think that question maybe is related because I don't know if they have any problem, but I have seen some issues on the vacuum pump happening, and the manufacturer, let's say, at the factory, they don't know it, they don't see it, right? And I think there is a maintenance process there that you need first a good brand. I mean, you need a proper brand casting machine, but then you need also proper maintenance.
Yes.
I don't think changing the brand of the pump will make any difference if you don't maintain it properly. Okay.
Another question: how can I avoid drying investment while debubbling?
This again comes back to the vacuum pump. Maintaining the vacuum pump. If you maintain your vacuum pump, you're not going to get any air bubbles on your casting. Your vacuum pump, check your pipe work regularly.
Filters.
When you're this is more so when you're investing on your vacuum mixer.
Yeah.
If the customer is conventional mixing by hand, make sure that they vacuum the bowl before they pour it over into the flask. Then they vacuum the flask after also.
All right. In stone setting, after finishing our casting, how long time it need to push in the flask in water?
Oh, this
Yes,
maybe 1.5 hours minimum. Minimum 1.5 hours. It has to be really cold. If they put the flask into the water, it's too hot. They will crack the stones. The thermal shock will crack the stones.
It's like putting something, very hot to something very cold suddenly, right? And you have basically a huge shrinkage happening.
Exactly.
So
that is
it will crash into it.
Yes.
And inside everything will be gone, I guess.
I saw also one of the questions was about I think the metal was breaking at the bottom of the flask. That again is also if they even if there's no stones, if they quench too soon, again it's metal. It's a thermal shock on the alloy that makes it break.
Yeah, my next question was this. Thank you for answering. Okay, and Mr. Mahan is asking for very fine structures. Is it good to use vibration during pouring the investment on the patterns?
I think it doesn't make a difference of the vibration, because generally the vibration, as we in the investment mixture process, is using the vibration to remove that gases. Generally the people have implemented these vibration things because they want to make sure that whatever the gas is coming out from the flask, they want to take it out and keep it going out from the machine. So if you have a very good vacuum systems, doesn't make any difference you have a vibration or not, because vibration is just to remove the gas, nothing else.
All of our vacuum mixers in all of our casting shops around the world, none of them use vibration.
Nothing.
But none. We don't have any issues with bubbling. But there's many vacuum mixers around the world that have this vacuum and vibration, and people believe that they are removing all of the air bubbles on the casting. No.
By the way, there
also,
is
it doesn't make also any grain size fineness. No, it is not like that. No,
it's on the vibration on the casting machine. That's when it changes the grain size of the structure size of the alloy, but that's out of my league.
Okay.
I want to say something because as due to the COVID situation, I spent a couple of weeks at home and I was reading a lot of different papers from the 80s and 90s. And as you know, Dave and Dipen, in the wax process, basically because you do injection wax, depending on your injector, depending on the powder you use, the silicone and so on, there are actually a lot of issues that can happen in the wax casting that are related to how you prepare your wax. Right?
Yeah, actually, as we are selling that, we are the last who tell you this is the problem, but it is not the casting machine problem. It is back to maybe the first step also, could be. So it's the whole cycle. What you see in the casting machine coming out, it is basically a result of all these processes.
So sometimes normal wax has issues that are not related to casting or burnout at all, but the way you inject that wax, the way you handle the tree and everything.
It can go even further back to the master model. If the master model has a slight imperfection, you make a rubber mold, you make 10,000 wax pieces. All those 10,000 wax pieces have that slight imperfection.
Yeah, that's correct. Today, any other questions?
Yeah, Mr. Robert. Yeah, Mr. Robert says that for heavy models, actually is a recommendation for us. For heavy models like watch cases, it's recommended to leave the flask out of the furnace for about 30-40 minutes. This will cool down the outside wall of the plaster, but not very much the center. This allows the plaster to absorb the metal heat on this, will give less or no surface porosity because of too much heat. Actually, we mentioned about this, but would like to share for the thick casting part.
I don't know what you think about that. I don't really agree, to be honest.
No. If they're using the correct investment powder, the permeability of the powder allows the alloy to flow. They want to get the heat out of the metal to have no porosity. But if you take the heat out of the alloy too soon, it then doesn't flow around. Okay, it's a large part. He's on about mentioning watch cases, but you still got to get all of the detail in there, the sharpness of the corners. So no, I don't believe it will help in any way at all.
One thing I also would like to mention, when you want to find your casting temperature, you remove, let's say you load on your oven and you remove your flask, but leaving your flask outside like 30-40 minutes, I think it may be very difficult to understand the real temperature of your flask, right? I have seen some customers doing that. They have two ovens. If one just to leave they put from one oven to the other oven which is already preset at the casting temperature, and leave it there. That's maybe a solution, I don't know, but it looks to me like maybe it's an experimental process, but I don't think it's very safe to do it because of the temperature, unknown temperature, I would say.
Yes.
Yes. One thing I will say is we are only all offering what the optimum solutions are. Many people in many different countries, I've been to many different factories, they do things slightly different, and they believe that that is their best way, their best process. So there is different processes that work for one person that won't work for another person.
Yeah,
as far as they are getting results, is good.
Yeah, that's
what
good.
they needed,
Any other?
Yeah, what will be the quenching time for rose gold? Because rose is tricky comparing to white or yellow gold.
I think it depends on the alloy that you are using. They have a completely clear data sheet.
Yes.
That what is the melting temperature and what is the quenching time. I think it's the best to follow what the alloy people are giving. I think most of the time some people doesn't know the data sheets. They just try it out themselves to experimental. But I would request always to first follow what the manufacturer is showing of the quenching time. If you are not getting results, then you can try some other things, or to contact the manufacturer again, or to the local your dealer.
In this presentation, we didn't talk a lot about the metallurgical part of the process, which is also very important. The alloy, the different type of metal you are using, and the quality of the alloys you are making. But I think for a webinar, this is quite difficult to explain, because I mean we can maybe one day do another one about that. The point is, this is very scientific, and you need metallurgical knowledge and proper knowledge to handle all that process. So the aim of this webinar, I mean, thank you for the question, but the aim of this webinar was mainly the general practice on the burnout, the casting of resin pieces. And now whether you use rose gold or white gold or yellow gold, then you will have a lot of different questions, I think, related to alloy.
Yes.
Okay, Mohamed Kurnazi from Lazurde is asking, what is the maximum burnout temperature we can use with the investment?
Mr. Kurnazi, how are you?
He's a great follower, and the last webinar as well, I think.
Yes,
Mr. Kurnazi was here.
So with the Protocast, we have tested it up to 800 degrees. We know it works, but we also, the maximum temperature we put on the burnout cycle for Protocast is the same as all of our regular investment powders, because we also know it works. Even with not with just Novafab resins, with other resins, it's a maximum temperature of 750, so that it can go in the same furnace as their regular investment powder for regular wax casting, so they don't have to have 2 furnaces, 3 furnaces.
Yeah. There's a question that I've seen. Percentage of gold loss, please. This is Mr. Mohammed. Any comments on that?
I think first of all, the gold loss is not the right word, as we know. There is gold never go loss when in the process of this melting and other thing. It is what we are talking about is the weight loss, which is what you are the other alloys which you are putting about the copper, zinc, or the alloy type of the things. So this is all things, and then there are a lot of factors which is affecting, because of it is when the metal is going and reacting with the investment. How is the oxidation takes place between, not the gold, because gold never goes. So other metal and your investment. Also, when it is melting, how is the oxidation, or how is the vacuum system which is taking out your zinc. So there are a lot of things on reacting there. Also, how you check it out is like you have a high purity when you see some weight loss is there. And some of the loss is very minimum that you don't see also a lot of high purity difference because of the other things. But what the most of the things also people lost the weight also when they do after the casting, they do the pickling, in the light acid when they do it. So there also nobody knows how much is going, because it depends on how is the acid, what is the boiling temperature, what is the process they are following. So there are a lot of factors where you can see that your weight loss is there. But first thing, sorry, the last thing in the mind, we don't have to use that word, the gold loss. In any machines, the gold loss, there is no gold loss.
One thing I had a question from one customer once. He asked me, how can I optimize my scrap metal to fresh metal ratio? And
Yes.
he was asking me whether I use like a 45 degrees angle or 80 degrees angle in my tree. And people obviously they want to optimize their fresh to scrap metal ratio as well. And
Yes.
the main the trees, the middle of the tree is your scrap metal. So any comments on that, Dipen?
Yes, generally, when you do, always the theoretical thing is like you always do fresh, but it is practical, it is not possible because of the gold availability and investment thing. So generally, what we recommend is when you do the fresh casting, then after you mix it up 50-50 or other things. Plus, it is depends on what kind of copper. If you are generally in the Middle East or in India also, 21 and 22 karat casting they are doing. So they are not using alloys, but the copper. So copper quality also defines a lot of things. How is the reusability and what kind of process then they are using? Because it must to clean before you put also your scrap. Generally, if you 50-50 after 2 or 3 castings, 50-50 you put it out, then it can be longer. But I have seen the people 9 castings, 10 casting they are using just to cut the tree and the things, and then they see I have a lot of gold loss, or I have a lot of other problems. Okay, it's a metallurgy and a lot of things are there.
Okay. Any
last questions? I have few. Mr. Pratik Patel is asking, I use gold cast powder and I get too much layers marks on that comes from resin, and also some texture that comes from powder.
Okay, so for the resin side, what I would say is, in the previous webinar, we discussed different type of resin, the castable resin we have. Now we have, for example, the dark resin we are using, which is a very sharp resin, and it shows all the details, but you can print at 25 micron with the dark resin. We have our opaque and wax resin, which smoothen the surface, and you can use that. So depending on the resin and what's inside the resin, the details that you get on the print may be different. So you use another resin, and we have, for example, our burn resin shows a bit more the details. But about the investment part, I think he mentioned the rough surfaces that we mentioned earlier in the webinar, but maybe you have some comments on that, Dave or Dipen?
Yeah, it's basically of the resin is more. I have seen as far as the layers is concerned, because of the printing. As I think you asked webinar, I have also attended. A lot of depend on the calibration of the the machine and the resin quality.
I mean, one thing is the layers, which you see because it's a layer-based 3D printer, and you can reduce them or not. The other question I think that he's asking is the surface related to the investment, and I believe we answered that because of the water.
Water powder.
Yes, powder water ratio.
It sounds like they were asking about the spalling.
Yeah, maybe
which we touched on. So
yeah, maybe we can go back to a few slides. In the meantime, if you have any other questions today.
What do you think? What do you think about heated vacuum chamber for curing resin?
Heated vacuum chambers, yes, actually in that paper, and there are some people using it. Now, again, if we speak about our resin, we don't recommend any post curing, whether it's heated, vacuum heated, or UV cured. And we just recommend to wash with ethanol, ethyl alcohol, and dry with compressed air. So that's what you do. Now, for other resins, I know they are doing different type of curing. At the beginning of our presentation, we mentioned what can be the effect of UV or heat curing. Now, vacuum heat is another process which can maybe improve. But, I think the problem starts from the chemistry of the resin. If you understand well the whole burnout cycle, and if as a manufacturer, you manufacture accordingly for casting resins, you shouldn't bother about this post-curing process, because it's also changed the shape or the shrinkage of the whole resin. In our previous webinar, we discussed a lot, and it's on our YouTube channel. But for our resin, we don't need any post-curing, whether it's heat or not. And it, by the way, post curing it will affect badly, slightly badly, the process in our case. Here it's the slide about the spalling issue. So if you have too much pressure escaping because you put either too much water or you have this flask that goes into very big temperature, you will have this chip and flakes that pops off. And I think that was the rough surface. Just to answer the other question. Any comments or any other questions? I think we have a lot of questions. I see them. Some of our team members are answering them as well.
Yeah, one question for Dave.
Yes.
Please tell me resin cast is same with cat cast from SRS.
Resin cast and CAD cast is very much the same. Protocast is slightly different.
What is the difference
Just
between Protocast and
because resin cast and CAD cast has been established in the market for many years, and there's many customers now that are using it and using it well. Protocast was redesigned because resins have evolved. The investment powder has to evolve. Many years ago, we started off with just Amiga Plus, only Amiga Plus for resins, but then resins evolved, so we had to go to resin cast, but we still had the customer base for Amiga Plus, so we couldn't just take it away from the market. So no, CAD cast and resin cast are still very good powders, and people still use them. Protocast is a new product that was designed because resins have evolved, and companies, and not only the resins, companies have evolved. Your company, when we first started doing resin powder, investment powder, your company wasn't there. So it's not just the resins have evolved, the companies have evolved. So the investment powder has to evolve.
And I think also what happens is the expectation from the customers changed as well, because what we have seen, at least on our side, in the last 3-4 years, a lot of people are moving to direct casting. So this is the big trend. They want to make light jewelry, surface or filigree jewelry, or even direct stone settings. And when you move from wax to resin, obviously everybody's trying different sorts of resin, and this is one of our success, because we were able to give good castable resin, and by doing that, a lot of customers move their production to direct casting. And when you move to direct casting and learn about investment casting machines, the resin and everything, the expectation is you want to get obviously the same result as wax, and you have to use a proper investment powder for that. And the investment powder manufacturers, as you mentioned, we are working together as well. So we are doing together tests on a continuous basis. And I think it's a normal process today. Just to answer that question.
Okay, let's say the last question, because all we are tired, I guess. After burnout of the crucible, does the gypsum gone?
Sorry, can you repeat that?
Sorry, can you repeat?
Yes, after burnout of the crucible, does the gypsum gone?
Okay.
There is some.
I think if you try to translate that, after the burnout, is the gypsum gone? No, the gypsum everything is still there. It's just expanded and changed its chemical formula.
Yeah. The gypsum is in there, the quartz is in there, the cristobalite is in there. They change in different forms, right, Dave?
Yes, yeah.
Just water is gone.
Just the water is gone.
Yeah. And I want to say one thing, by the way, just my feedback about this webinar, because, jewelry industry, and particularly, I think, casting, is a very closed, secretive, what we can say, community or society. So if some people have a very good casting, they don't sometimes want to share it, or but as a company, and I know Dipen, you are the same, and Dave as well, we open and we share as much as we can. So if people have questions, they can always ask us directly. And we are sharing all information we have, and we don't want to, because it's like cooking, and people in their kitchen, they always try to do special tricks and hide so that they can have a better performance. But knowledge is there. It's a science at the end of the day, and we are here to share it. So if you have any questions, I think
any questions there that they want to ask, all of the details are on the screen now, so they are free to email, to WhatsApp.
WhatsApp, yeah.
Yeah. There is one question I've seen just about hollow jewelry. If you make direct casting, how can I get good finish inside the surface? So obviously you polish it, and most of the time you polish outside, but there are some polishing machine that will also polish inside, right, Dipen? Do you have any experience on that?
Yes, yes, of course. There are many polishing systems and techniques are there that can give you very good results. So there is all, I think, different seminars we have to keep it for the finishing and polishing.
Yes, electro. I think for inside
electro polishing
is electro polishing. Yes.
Maybe we should do one about just polishing, because this is also another big topic.
Yeah,
there are so many topics. Okay, I think we can ramp up. I mean,
yeah, we are all done. All done.
I want to thank first of all our attendees, because we had a good number of attendees today. Thank you very much, Dipen. It's great to have you here. I hope we will meet soon face to face. Same, Dave. Thank you very much.
Yes.
You still have the sun in UK here?
Just about to set.
Yeah. Thank you very much, everybody. Thank you, Tulay.
Thank you.
Yeah.
Thank you.
Thank you, Mr. Hakan, for inviting us.
Thank you.
And see you at the casting floor, guys.
Yeah, we need to work harder, And Dave, we are still going on with the R&D
yes,
side.
For sure.
And I just want to say, and Tulay, you will probably repeat that. We want to do these webinars on the jewelry industry on a periodic basis. So please, Tulay, tell us more about it on our next webinar.
Yeah, our next webinar will be about our design platform.
Oh.
We will launch it in our Instagram and Facebook accounts, and please follow us on YouTube to have this webinar record. And you can email me any of your questions for recommendations, for any technical questions to resolve or forward to Dave or Dipen at tulay@3bfab.com.
Also, I want to say, if there are a lot of questions and they have some casting failures, they could send us all those pictures, and maybe if you guys have time, we can maybe set up a webinar, just question and answer about, this mistakes is about that picture is about that, something like that. But follow us, everybody. Thank you, Dave. Thank you, Dipen. Thank you.
Thank you.
Thank you.
Everybody stay safe.
Thank you. Stay safe, yes.
Yeah, stay safe, everybody.
Bye-bye.